Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is Introduction to Ground Improvement Techniques Problem Solving. So, in previous also we understand what kind of situations we are facing for the problem statement. As per the problem statement, based on the problem statements, how many ways are there, what kind of different techniques they may involve in that particular problem solvent based on the type of the soil, and what kind of technique gives the which kind of desired property for getting the better construction. So here we are understanding in this particular lecture, we are understanding with numerical examples. So here soft clayey soil under building foundation. We'll see what is theoretically, we understand what kind of techniques we may choose. Here in this, the practical example comes under, suppose a 10-story building is to be constructed on site where the soil consists of 10 meters of soft clay with an underlying shear strength of 15 kPa and natural water content of 40%. The building imposes an average pressure of 120 kPa on the foundation. So such kind of numerical we are understanding based on the numerical values. So here what we will do in this kind of problem. So in this the given is the low bearing capacity and high compressibility of the soft clay. So and also it is there is a chance to the undergoing of significant settlement which could lead to the uneven foundation settlements that leads to the structural damage. So those kind of problem statement what we understand in this, the step-by-step procedure is involved in this particular method. Technique what we choose is the preloading with vertical drains. So the method we choose, that is the preloading with vertical drains, because of all the properties according to this we understand. In this, the first thing we are going to do is the estimate the settlement without improvement. So immediate settlement is calculated using this formula. So in this, Q0 is the applied load, mu is the Poisson's ratio, E is the modulus of velocity of the soil, H is the thickness of the clay layer. So here these are all they given. So according to this we are finding the immediate settlement. It denotes in SI, suffix I. So here that Q0 1 minus 2 mu square divided by E into H is the formula. Here Q0 is equal to 120, 1 minus 2 into 0.5 square by E is the modulus velocity of the soft clay. Otherwise we are going to conduct the laboratory test for finding the modulus of velocity during some conducting some tests. Then only we will understand the soil properties. For understanding the soil properties, we are doing, according to that, we are doing the tests. So that we may understand the things. Here thickness of the layer is 10 meter. Finally, we will get 720 mm. Or in terms of 0.72 meters. So like this, we are understanding the initial settlement without improvement. Now in step 2, apply preloading with vertical drains. So here we have to we are applying the techniques. So here we understand what kind of settlement, what kind of parameters are involved in this. We will understand. Now move on to this. We are going to assume vertical drains are installed at spacing of 2 meters. Here we are assuming the vertical drains are going to space every 2 meters is the key parameter in this particular thing. The primary consolidation settlement after preloading can be calculated using the following final consolidation settlement. That is equal to Cc into height. Cc is nothing but the compression index, and H divided by 1 plus E0 is equal to initial void ratio and log of. So this is the formula. In this, the term is nothing but it is the final effectiveness, final effective stress, and this is the initial effective stress. Using this formula, we are understanding the we are getting the final consolidation settlement. So apply preloading with drains. So this is the step we will follow, that is the final consolidation settlements. In this rate of consolidation, using the coefficient of consolidation, calculate the time required for 90% consolidation. So that is equal to time required for this is the formula. So according to this, we are going to H is the drainage path length, T is the time. The additional vectoral length significantly reduces the drainage path, speed of the consolidation. So like this, we are going to calculate the how much time is required for this particular scenario. So in this, what we understand? So according to this, assume we do the as per the assumptions. So we are doing the 90% consolidation and H is the drainage path. So after done the calculations, we will know the how much time is required for this in terms of months or in years. Months or in years we are going to calculate. So by applying this kind of preloading with vertical drains, the soil's consolidatal is accelerated, reducing the risk of differential settlement. So the numerical analysis show that preloading can significantly reduce the further settlement, making the site suitable for the building. So for that, we are choosing the method which we follow for the ground improvement. Which ground improvement technique we will follow. Now, in this, the second other kind of technique where we used and what kind of problem statement we will understand, that is loose sandy soil prone to liquefaction. In this, consider a coastal site with loose sandy soil which is proposed for a new residential development. The water table is close to the surface and the site is an earthquake prone area. The soil's relative density is 30%, make it susceptible to liquefaction during seismic event. So in this, the problem, liquefaction could cause the soil to lose strength during an earthquake, whether based on the seismic waves, leading to ground failure and damage to structures. In this, we choose this vibro compaction technique for getting the desired properties of the soil. At the time of earthquake, what are the, when it is loose soil, now it need not to be the damage to the structure and any kind of ground failure, it could not be happen. So for that, we are choose this vibro compaction technique, ground improvement technique. Here the step 1 is determine the required improvement depth. So based on the site investigations, once we understand the what are the soil properties and their according to their numerical values, we understand this loose sand extended to up to 10 meters, depth of 10 meters. This vibro compaction will be applied to densify the soil. Here the first step is involved. We are understanding the how much depth improvement is required based on the soil investigation. Now move on to the step 2, that is calculate the required relative density post improvement. To reduce the liquefaction risk, the relative density should be increased at least 70%. And the initial void ratio can be estimated from the soil's relative density using this formula. That relative density is equal to E max minus E naught by E max minus E minimum. Here assume E max is equal to 0.8 and E minimum is equal to 0.4 for relative density 30%. Solve for E naught. Here we are understanding this is equal to 30 centimeters, this relative density. E max is equal to 0.8 minus E naught divided by 0.4. That gives the final calculation 0.68 is the E naught. After vibro compaction, the target is 70%. So post it should be increased at least 70%, but the post it is 30%. So before doing the technique, the relative density is 30%. After reaching that, that gives the 70%. So here that is equal to E max minus EF, here that is final, and E max minus E minimum. So E max and E minimum is same in both the cases. So that is 0.4, 0.8 minus E final. So that gives the final one. So like that we are understanding, we are calculating the required relative density before and after. Now, how much volume reduction required? We are going to calculate how much volume we are going to require. So using this formula, we are finding the how much volume is required, that is equal to H into E naught minus EF by 1 plus E naught is the formula. When we are applying all the values into this formula, finally we will get 0.98 meters. That much volume is going to be reducted. So in this, the vibrocompaction process densifies the soil, increasing its relative density from 30 to 70%, reducing the void ratio and making the soil more resistant to liquefaction. So the numerical method provides a quantitative assessment of the improvement in soil properties, ensuring the safety against seismic risks. So these are the things we are going to understand according to the chosen technique. We are following this step-by-step procedure for getting the desired properties of the soil. So and one more is that is equal to embankment on soft soils. So an embankment for highway is planned over a site with soft clay extended 15 meters deep. The clay has a high compressibility with an estimated consolidation settlement 1 meter over 10 years under the embankment road. So these are the numerical values. We are understanding this practical example. In this, the problem statement is it is soft clay, low strength and high compressibility could lead to the properties are there for this soft clay. So for this, it leads to the excessive and uneven settlement. In the property, the settlement is equal to affected on the embankment, potentially causing cracks, and also it leads to the failures. So this is the status of this. Now we are choosing the technique, that is prefabricated vertical drains and surcharge preloading we consider. So here first we understand estimate the settlement using conventional methods. So the primary consolidation settlement is calculated. So according to that, the primary consolidation coefficient of the things we are understanding in this. So according to that, we are finding the mathematical calculation. So finally, we will get the primary settlement is equal to, after calculation, that is equal to 3.4 meters. In application of prefabricated drains, assume PVDs are installed with a spacing of 1.5 meters. The degree of consolidation can be calculated using the formula U, the degree, that is equal to 1 minus expansion pi square TV by 4. Here, this TV is the time factor based on drainage conditions. Where with PVDs, the drainage path is short and speed of the consolidation. So here we are understanding according to that HT is nothing but the drainage path. So this T gives the how many number of days is required. For the number of days or years or months are required, we will get for getting the required settlement, for getting the desired required properties of this kind of solution. So like this we are understanding the things. In this, use of surcharge preloading, a surcharge load is applied, increasing the effective stress is equal to 200 kPa. The additional stress accelerated consolidation, reducing the time required to achieve the desired settlement. So like this, all kind of various PVDs and surcharge preloadings and various combinations we are going to understand. In observing these three different types of numerical methods which we follow for these ground improvement techniques, what we understand is that according to the problem, according to what we consider is that as per the type of soil and based on what type of construction work we are going to do, type of soil and what type of construction work we are doing, our project we are considering there. According to that, we are going to choose the technique. Why? Because type of soils gives what are the properties are going to there in that particular soil. Based on the construction type, we are understanding most important parameters. What are the actual properties which we are going to understand in that particular technique? So now we are going to choose the technique, whether these properties are going to modified because of the technique or not. So these are the things we are going to understand in our ground improvement techniques. So each type of soil and type of construction may suggest two to three different kind of techniques they may consider. Among that, according to the practical scenario, we are going to choose the technique among the availability of the suggestible techniques. So in that we are understanding this based on the significant we are choosing. Once we choose, we are going to follow the procedure. In the before and after, as per the required property, we are doing the test for that particular properties. Not only properties, there may be properties. So before and after the technique, we have to understand the soil properties. Then only we will understand whether it is reached the desired properties or not. That gives the better understanding about these techniques and as well as the properties where they may affected or not. So in this, by combining the PVDs with surcharge preloading, the consolidation process is significantly accelerated. So these kind of combinations may helpful for the required property is not or is effective or not. We may understand using these tests. Based on the tests before and after, we are going to understand. The time required for the process is also very, very important. It may affect the construction schedule of the construction project. So according to that, we are going to choose how much time is there for starting to start about the project. So these are all the parameters for a better understanding about this technique and how much time is required for that particular technique for getting the desired properties, or whenever we are going to start that particular work. These are all the parameters we have to understand. In these conclusions, these practical institutions for these how ground improvement techniques are applied in real world scenarios using various methods. So the calculations help in quantifying the improvement in soil properties, ensuring the safety and stability of the construction project. Each technique is selected based on the specific soil condition and nature of the problem. So providing these all kind of whatever the step-by-step procedure, not in detail, for challenging the geotechnical problems. So here we are going to understand what kind of scenario it is there. Based on that, we are choosing it depends upon the specific conditions of the soil and also the nature of the problem for choosing the, plays a key role for choosing the better technique. So these are the things we are going to understand in our ground improvement techniques. So in the overall view of these ground improvement techniques, so in this we are understanding the various kinds of types of soils. According to that, what is the step-by-step procedure involved? So the procedure is different where we are using for the what kind of property is going to improve and which type of problem statement it is. According to that, we are going to choose the respective technique. So it may fewer options may be available. So those options we are going to choose based on the property. We are going to choose which technique gives the desired property. So like this, we are understanding all the parameters. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.